Hello students. Today let us start with our first unit, Introduction to our AI. In this AI we have come across the terms known as electronics, and measurement and instrumentation. So let us first define that what is the definition of those things. Coming to our first definition, which is known as an instrumentation. Instrumentation is a technology of measurement which serves sciences, engineering, medicines and etc. So what is instrumentation? It is nothing but it is a measurement. Okay, instrument, by using an instrumentation only we are going to have a measurements of various different quantities. So those quantities can be linked with your science, or it can be linked with your engineering, or it can be linked with your medicines. So it will be related with your quantities which has been available as in the science. Like in science or in engineering we'll go with the voltage calculations, power calculations. You are going to measure the current flow. So these are various quantities. To measure that particular thing we need an instrument, and the technology which is used for measurement is known as an instrumentation. Coming to our next definition, what is measurement? A measurement is a process of determining the amount, degree or capacity by comparison with the accepted standards of the system units being used. So it is nothing but a measurement is nothing but it is a process. You are going to use a process to determine the amount. Okay, whatever the quantity you are going to have, for that one what is the amount, what is the degree, or what is the capacity, okay, it is going to hold, that you are going to determine. Okay, this will be determined by comparison with your standard system units. You are going to have a standard system units, by that you are going to compare it and you are going to determine the amount of measurement. Okay, like for example if you go with some weightage calculations, when you put some quantity in on your weight machine. Okay, that weight machine will be going to show you that the weight of those particular quantity is nothing but these many kgs or these many grams. How it has been showing, it is the way what is the weight of that particular quantity is been compared with your standard system units, and then it will be showing that the that particular quantity weight is 1 kg or of kg, or it can be 100 grams. So that is nothing but your measurement. Coming to our next definition, instrument. Instrument is a device for determining the value or magnitude of a quantity or variable. So instrument is nothing but it is used to, it is a device. Instrument is nothing but it is a device to determine the value or magnitude of a quantity. Okay. Now when I'm saying that to go for to calculate the weight of this particular mangoes. Okay, so I have used 4 mangoes, and if I'm going to purchase these 4 mangoes, so these 4 mangoes first it will be placed on the weighing machine. Okay, to measure the to go for the measurement. Okay, so the device which is used to measure, then that device is known as an instrument. Coming to our next definition, electronic instrument. Electronic instrument is based on electrical or electronic principles for its measurement functions. So here in electronic instrumentation, we will be going to use the components to build an instrument, are nothing but your electrical or electronic components we are going to use to build the particular instrument. Okay, so these are nothing but some basic definitions related with your AI. Let us come with the next part. So what are functions and advantages of your instrumentation? So the 3 basic functions of an instrumentation are nothing but your indicating, recording and controlling. What is indicating? Instrumentation means you should indicate, you should visualize that this is a weight. Okay, that is nothing but your visualization of the process or operation. Recording is nothing but your observing and save the measurement reading. We need to observe and then we need to save that particular measurement reading. The next one is what? Controlling. Controlling is nothing but to control the measurement and process. How we are going to control the measurement and process? So these are the three basic functions of an instrumentation. What is the advantages of your electronic measurement? Results in high sensitivity rating. Okay, it is going to have a high sensitivity rating. And the second one is nothing but your increases the input impedance. It is going to increase the input impedance, thus lower loading effects. Okay, loading effect will be lower. Okay, ability. Next one is advantage is something with your ability to monitor the remote signal. So it is going to have the ability to monitor the remote signal. Coming to our most important thing is something about your performance characteristics. So when I go with my instrumentation, I should know what is the performance characteristics of that particular instrumentation. So what do you mean by performance characteristics? A characteristics that shows the performance of an instrument. So generally when I'm going to say characteristics is nothing but it will be going to show the performance. So the characteristics that shows the performance of an instrument is nothing but it is known as an performance characteristics. Examples of performance characteristics are nothing but your accuracy, precision, resolution and sensitivity. So in performance characteristics we are going to find out the accuracy, precision, resolution and sensitivity. So what does it will be? What is the main important thing of your performance characteristics? It allows a user to select the most suitable instrument for a specific measuring jobs. So for measuring any jobs, what is the best instrument which we require? We are going to select that particular instrument. So the main two important characteristics of this performance characteristics are nothing but there are two characteristics. One is based upon your static and the second one is based upon the dynamic. A static is nothing but measuring a constant process condition. Constant process condition is nothing but the quantity, the physical quantity which you are going to measure, that physical quantity will be a constant value. Okay, it will not be going to have a variable from one second to another second. So that characteristic is known as a static characteristics. What do you mean by dynamic characteristics? A dynamic characteristic is nothing but your measuring a varying process condition. It is going to measure the varying process conditions. So how it is been going to vary? Like for example, if I want to measure my temperature, so the temperature will continuously vary from one part to dynamic measurement is nothing but the temperature will continuously vary. So this is known as a varying process condition. So basically this performance characteristics again it will be classified as in two types based upon your type of measurement. Whether you are measuring a constant quantity, then that is known as a static one. If you are going to have a dynamic, then it is known as a varying physical quantity, then it is known as a dynamic measurement. Like weather report, it is a dynamic, it continuously changes based upon that one. Okay, when you go with the static measurement is nothing but your some purchasing some kirana store item or purchasing a vegetable where the quantity will remain constant. That is something but I'll be going I'll keep some mangoes or fruits on the weight machine. I'll just calculate the weight, that's it. So this is known as a constant measurement. Coming to our performance characteristics, So I have told you just now that in performance characteristics we do have accuracy, precision and resolution and sensitivity. So let us get into the definitions of those things. In performance characteristics, what do you mean by accuracy? Accuracy is nothing but the degree of exactness, closeness of a measurement compared to the expected desired value. So how much accuracy? That is nothing but if I say that it is 1 kg, so do I am getting correct to 1 kg, or do I am getting something less or something more? Okay, never you will get the exact value. And when you go with the weighting type, any measurements, okay, so 99% you will be going to get the closeness to that particular exact value. You will be going to get the exactness, closeness measurement compared to the expected value. That is known as an accuracy. What do you mean by resolution? The smallest change in the measurement variable to which an instrument will respond. Okay, so resolution is nothing but if I change very small, very short, small type of quantity, so the instrument should respond to that small variation. So that is known as a resolution. So few of the measurement instrumentations, what it will does, if I keep a certain for example, let us take the same example of your weight machine. In the weight machine, if I put some 1 gram of my weight, there will not be that much change in my resolution. If I keep 10 grams of my weight, then only that weight machines will go with up and down, so the resolution will change over there. Okay, so that is nothing but your resolutions. If suppose if you're planning to purchase some gold or something like that, so what happens, the resolution over there should be very little. Why? Because the 1 gram also it makes a lot of changes, whereas when you go with the purchase of your fruits and vegetables, 1 gram doesn't make any change. So keeping so when you go with the purchase of any instrument, you should have an idea that what is the resolution of that particular instrument. The next one is what? Precision. What do you mean by precision? A measure of consistency or repeatability of a measurement. That is, successive reading do not differ. So what you will be going to do here? You will be going to have a successive readings. That is the same quantity I will be placing on the weight machine. I will be taking the readings continuously, repeatedly I will be going to take the readings. If the readings is nothing but it will be constant, that constant is whether it is a constant or it is varying from 1 second of measurement to the next change of measurement. Okay, that is known as a precision. Okay, here we will be going to, in precision we will be going to take a repeated head measurements. The next one is what? Sensitivity. A sensitivity is nothing but a ratio of change in the output response of an instrument to a change in the input or measured variable. Okay, as that is it same thing like your resolution only. So the percentage of change, the ratio of change, if I change my output, if I change my input, little bit input, what have the change in the output is, how much is the change in the output? That is nothing but your sensitivity. The next definition is what? Expected value. So what is expected value is nothing but your the design value or the most probable value that expect to obtain. Okay, what we are going to expect, okay, what we are expecting, whether the desired value which you have got it or not. Okay, so that is known as an expected value. What do you mean by an error? Error is nothing but the deviation of the true value from the desired value. Okay, deviation from the true value to the desired value is nothing but I need to get 1 kg, but it is not getting a 1 kg, I am getting only 900 grams. So that is nothing but the change in the value, okay, from 1 kg to 100. So I'm losing 100 grams over there. So that is nothing but your error in my instrument. So these are nothing but your some of the performance characteristics of your instrumentation. So these are nothing but some of the performance characteristics of your instrumentation. Whenever you are trying to purchase your instrumentation, you should have an idea about that. What is accuracy, resolution, precision, sensitivity, expected value, and error. Coming to our errors in the measurement. So what type of errors are there? We'll be going to see. How you are going to measure those errors, we'll be going to see. So measurement always introduce an error. So whenever you go with a measurement, compulsory there will be an error. Now you should know that what is a percentage of error have been occurred. So how you are going to calculate that percentage of error? So what you will be doing, error may be expressed either as an absolute or percentage of error. So what is a percentage of error? We should know. So how we are going to calculate? So absolute error E is nothing but it is equal to yn minus xn. What is yn? Yn is nothing but your expected value. What is xn? Xn is nothing but your measured value. So the difference between the expected value to the measured value is known as an absolute error. So what will be the percentage of error? Percentage of error is equal to the absolute error divided by the expected error value. Okay, so that is nothing but your, what is my absolute error is nothing but your expected value minus measured value divided by the expected value into 100 is known as a percentage of error. Okay. Next comes to the relative accuracy. Relative accuracy, how we are going to find out? 1 minus expected value minus what it is? Expected value minus measured value divided by expected value. Okay, 1 minus expected value minus measured value divided by expected value. This is known as an relative accuracy. What is the percentage of relative accuracy? Is nothing but your A is equal to, small a is equal to 100% minus percentage of error. What is my percentage of error? Percentage of error is nothing but your this one. So this is nothing but your yn minus xn by yn into 100. So what is the percentage of error? You have got it here, that you are going to remove it from the 100%. That will be giving you the percentage of your accuracy. Or you can calculate the relative accuracy and multiply with the 100. That will give you the relative accuracy. So this is related with your accuracy. Coming to our next calculation, which is known as an precision. Precision P is equal to 1 minus xn bar divided by xn bar. What is xn? Xn is nothing but your value of the nth measurement divided by the average set of the measurements. So that is nothing but a precision. I have in the definition I have already told you that repetitive measurements is known as a precision. So continuously you are going to vary, then that is known as a precision. Okay. What is precision? Precision is nothing but a precision of a measurement is nothing but a quantitative or numerical indication of the closeness with which a repeated set of measurement of the same variable agrees with the average set of measurements. So repeatedly I will take the same quantity, I will measure it. When we are going to measure it repeatedly, we will be going, the value should be same. Okay, whether it is we are going to get the same variable variable agree, or you are going to the different measurement, that you are going to get it from the precision calculations. Or precision P is nothing but your 1 minus value of the nth measurement minus average set of the measurement divided by average set of measurement. This is known as a precision. Okay, let us take one example, you will be understanding here. So what is the question here is asked here? Given expected voltage value across a resistor is 80 volts. The measurement is 79 volts. Calculate the absolute error, the percentage of error, and the relative accuracy and the percentage of accuracy. So here what is the expected voltage value across a resistor is how much? Expected value is what? 80. And what is the measured value is what? 79. So what is absolute error? Absolute error is nothing but your expected value minus measured value. So that is nothing but your 80 minus 79, that is equal to 1 volt. What is the percentage of error? Percentage of error is nothing but your expected value minus measured value divided by expected value into 100. So that is equal to percentage of error. What is percentage of error? It is 1.25 percentage. What is relative accuracy? Relative accuracy is equal to 1 minus yn, that is expected value minus measured value divided by expected value. So if you calculate it, you got it as you will be getting as 0.9875. So the next one is what? What is percentage of accuracy is nothing but your relative accuracy into 100 is nothing but your percentage of your accuracy. So in this way you are going to calculate your absolute error, percentage of error, relative accuracy and the percentage of your accuracy. What is limiting error? Let us come with a limiting error. It is one of the important things in your instrument. The accuracy of measuring instrument is guaranteed within a certain percentage of full scale reading. Okay, limiting error is nothing but whenever you are going to design any instrument, there will be a particular in the manufacturing you will be getting some error, pakka error you will be getting. So how much that error will be, that it will be indicated by the manufacturer only. It will say that this much of tolerance or this much of error will be compulsory there in that one, based upon your full scale reading. So from full scale reading we will be going to remove that much percentage of your error, then only the value you will be getting, that value is nothing but your correct value. Okay, so the value which is been limited by the manufacturer is known as a limiting error. Example, manufacturer may specify the instrument to be accurate at plus or minus 2% with full scale deflection. So what do you mean by here is nothing but your plus or minus for 2% means whatever the value which you have got it, for that value you need to remove 2%, and what are the value which you will be going to get is known as an correct value. The accuracy it has been measured over here is to plus or minus 2% of full scale diffraction. Calculating that value is nothing known as a limiting error. Okay. For reading less than full scale diffraction, the limiting error will increase. Okay. Let us take one example and let us see that how we are going to calculate the limiting error. So here given a 600 voltmeter with an accuracy of plus or minus 2% full scale. Okay, calculate the limiting errors when the instrument is used to measure a voltage of 250 volts. Now in this, what is a voltmeter range? It can measure from 0 to 600 volts. Maximum it is going to measure 600 volts. What is the accuracy here saying? Plus or minus 2% of full scale deflection. So what I am going to do, first I need to calculate the magnitude of the limiting error. How we are going to calculate the magnitude of the limiting error is nothing but your full scale deflection is what? 2%. 2% means 2 by 100. 2 by 100 is nothing but your 0.02. That value should be multiplied with your voltmeter full scale. What is that full scale value you are going to measure? That is 600 volts. So you are going to multiply 0.02 into 600. That gives us to 12 volts. So this is 12 volts is nothing but your magnitude of the limiting error. So therefore the limiting error for 250 volts is what? I have measured 250 volts. So for this one, what is my limiting error? Limiting error is nothing but your magnitude of the limiting error divided by the measured value. How much I have measured? 250 volts into 100. So that is 12 by 250 into 100. You have got it as a 4.8%. So this is your limiting error. That much of limiting error is there in your particular value which you have retaken the reading. So this is nothing but how you are going to calculate the. Coming to our next important component is nothing but significant figures. Significant figures convey actual information regarding the magnitude and the precision of the quantity. So significant figures convey the actual information regarding the magnitude and precision. What is the magnitude and precision of a quantity? That actual information will be conveyed. That convey is nothing but it is known as a significant figures. More significant figure represents greater precision of measurement. So if I am having more significant figure, then the greater precision of measurement you are going to get it. For example, if I am going to take an example, find the precision for the value of x1 and x2. Okay, xn bar, that is nothing but your average set of value is nothing but your 101. What is x1? x1 is nothing but your 98. Okay, x2 is nothing but your 98.5. So that is nothing but your first significant first precision value is first calculation is nothing but your 98, which is nothing but your significant figure, and the second calculated significant figure is 98.5. Average set of value is nothing but your 101. So what happens to my x1? For x1, what is the precision I will be going to get? 1 minus. What is a measured value? What is a value I have measured over here is nothing but your 98. So what is the average set of value is nothing but your 101. So what is measured value is nothing but your 98 minus 101. Average set of value divided by average set of value, which is equal to 0.97. In the same way, your x2 will be also calculated in that is precision 1 minus 98.5 minus 101 by 101. So that is nothing but you have got it as 0.97 or 0.975. So if you see here, x1 has the less precision and x2 has the more precision. Okay, so in this way you are going to calculate the precision. When you do this calculations, you should be knowing this one. Sometimes he may pose you the questions based upon the accuracy, precision. Okay, that's in the final exam. So that's all for the today's session. Okay, thank you. In the next session, we'll be going to see that what are the types of errors. Okay, and how we are going to measure those types of errors we'll be going to see in our next class. Thank you.